Hi, my name is Ryan and you're watching my YouTube series on functional programming. In this video, I'm going to talk about the maybe container. In the previous video, I showed you how to create a simple container called container, and all it did was define a map function which accepts a transformer function and executes that function on the data stored inside of the container. This is a very simple container. It did not really do anything special. It's also called as the identity container. So what we're going to do now, we're going to do something different with our container. In fact, we're going to call this the maybe container. So we're going to say maybe. And instead of simply executing the function that we did in the container, container, right? We're going to do a conditional execution. So we're going to say if this dot data is equal to undefined, or this dot data is equal to null, then return a maybe dot of null, or we can just say return itself, which is the same thing, because if you don't have anything, you return yourself. It's not going to make any difference. But let's see how this actually makes sense in terms of code. So if we say let's define a variable called result1. I'm going to use result1 because I'll be using result2 as well. So we're going to do maybe dot of, let's say 10, and let me copy this function that I made here, which is a simple function which adds 2 to its argument, and I'm going to do dot map add 2, and then I'm going to do this a bunch of times. So I'm going to add 2 3 times, or let's say 4 times, and let me console.log result1. So now let me run this. What I get is a maybe which has the value 18, which is 10 plus adding 2 4 times. Now let's add a little bit of a twist to this. So my result 2, instead of passing 10, I pass in nothing, or if I pass in null, which is the same thing. So in this case, I have the exact same code, right? And you're trying to run the add to function a couple of times on a null, which should actually fail. Or it might be a divide by 2 function or anything of that sort, right? So what would happen here if I print result 2? You're going to see that my program did not fail. It ran through and I got a maybe with the data of null. So if you think about it, all the magic lies in the map function here. The map function said, okay, if my data is empty, do not execute the transformer function. Just let it go. Just send yourself back, which is nothing but a container which has a null, so it can be mapped on. But even though it is empty, you can continue mapping on it and nothing will happen. Whereas if you have data, you execute the function and then you return a wrapper. And in order to make this a little more cleaner, we can take this out of here and make a function called as isEmpty with which checks return this, and I can always do isEmpty. This dot is empty, and I'm going to clear my screen, try to run the code again. As you can see, it makes no difference. The output is the same. There's a minor refactor over there. So this is very nice because now you can handle errors in your code, and your program will not break because the executing function, the function that you want to execute, will not get executed if there is no data, and this makes your code a lot more safer to write. That's about it.